Hello everyone, welcome back to this YouTube channel, IBwontcrushyou, and today we are dealing with measurement from the chapter Geometry and Trigonometry, and we will deal with some exercises. So let's get started. Problem 1. A sector of a circle has radius 12 centimeters and the central angle of 60 degrees. A. Find the area of the sector. So in here we have to use our booklet, and of course you have it on your exam, and we have to look for area of a sector, and it looks like this. A equals angle, so our theta, divided by or over 360 times pi times r squared. And now we have to substitute our values, so 60 over 360 times pi times 12 squared, and we have to calculate it. And the answer is 75.4 centimeters squared, and here we can leave the three significant figures as in your final exam. And B, find the arc length of the sector. So here also we use our booklet and the formula for arc, so for the length of an arc. So L equals theta over 360 times 2 pi times r. So now we have to substitute our values once again, so 60 over 360 times 2 pi times 12, and this is 12.6 and centimeters. C, imagine that the sector is folded so that the two straight edges meet and form the curved surface of a cone. Determine the height of this cone. So firstly, maybe let's imagine this situation. So firstly, we had a circle, and circle has an arc. So let's graph it like this. Here we have radius, so 12 centimeters, and here we have 60 degrees, so our angle. And now we take it and fold it. So this is connected with this, and from this we have cone, and here we have base, something like this. So this radius is in here because it's our slant height as radius from our circle, and here we have our length, this length. So it's like it's basically the circumference of this circle, so the base of our cone, so 12.6. And now, because we know our circumference, so 12.6, we can calculate radius from the circumference circle formula. So from C equals 2 pi r, so 12.6 equals 2 pi r. Now we have to calculate r from the solver. So r equals 2 centimeters. So we know that this radius is equal to 2 centimeters. And now we can use Pythagorean theorem to calculate our height, because here we have right angled triangle. So basically our 2 squared plus h squared equals 12 squared, and we can calculate it in our GDC. And the answer, so our height is equal to 11.8 centimeters. Problem 2. A water tower consists of a cylinder of height 20 meters and diameter 12 meters, topped with a hemisphere. A. Find the total capacity of the tower. So firstly, let's write the formulas for the capacity of a cylinder and hemisphere. So capacity is basically volume, and you have these formulas in your booklet. So these are our formulas, and you're not given hemisphere volume formula in your booklet. However, you're given sphere formula. So we know that hemisphere is a half of the sphere. So basically we have to multiply it by half, so 1/2, and this is the formula for the volume of sphere, and 1/2 because we take only a half of the sphere, so hemisphere. And now we can substitute our values. So here we have pi times we have diameter 12 meters, and here we have to be careful because in our formulas we only take radius, and radius is half of diameter. So times 12/2, or just 6, and of course squared, and times height, so times 20, and we'll calculate it in a minute. And here we have 1/2, and in bracket 4/3 times pi, and times hemisphere. Hemisphere basically it is connected with our cylinder, so they have the same diameter, so the same radius, so times 6 to the power of 3. And now we have to calculate these values. So these are our answers, and I left them with pi because with pi we have more exact value, because now we have to add them, so it's better to leave them with pi. And now we can add them and calculate it. So it's 2714.33 meters, cubic meters. And B, the tower is filled with water to 80% of its capacity. How many liters of water does it contain? So our capacity that we found is our maximum capacity, so 100%. And we know that we're asked about how many liters of water. So let's firstly change our unit from cubic meters to liters. So we have to multiply our answer with 1000. So that's it to change the unit. So 2714.330 liters, and this is our maximum capacity, so 100%. And in order to have 80%, we have to multiply our answer. So 2714.330 times 0.8, and now we have to calculate it on our GDC. So our answer is 2,171,464 liters. And C, find the external surface area of the tower that needs to be painted. And in order to do this, we have to have our formulas for areas of a cylinder and hemisphere from our booklet. So these are our formulas from the booklet, and now we have to just substitute our values of height and radius. So for the cylinder it's 2 pi times 6 times 20, and for the hemisphere this is the formula for the surface area of a sphere, and here we have half of it, so for the hemisphere, so 1/2 4 pi times r, so 6 squared, and we have to calculate it. We can leave it with pi because at the end we have to add both values to have a whole area to be painted. So these are our answers, and now we can add them. So 240 pi plus 72 pi, and it equals 980.18 and meters squared. Problem 3. A lighthouse consists of a cylinder of radius 4 meters and height 12 meters with a cone of height 6 meters placed on top. A. Find the total curved surface area of the lighthouse. So firstly, let's just rewrite formulas for the surface area of cylinder and cone. So these are our formulas, and now we can substitute our values from the command. So here we have 2 pi times radius of a cylinder, so 4 times 12, so our height, and cone pi times r, so radius also 4 because a cylinder is connected with cone, so they have the same radius, and times slant height. And here we have a problem because we are not given slant height, so we have to calculate it because we cannot substitute just height, because in a cone we have something like this. This is our height, and this is our slant height. And as you can observe, this forms a right angled triangle. So we're given our height, so 6 meters. We know the radius, so 4, and we're looking for L, so we can simply calculate it for Pythagorean theorem. So 6 squared plus 4 squared equals L squared, and we can easily find it on our GDC. So slant height is 2 and square root of 13, so we can write it in here. And we have to calculate both areas, surface areas, and then add them. So these are our answers, and now we have to add them. So 96 pi plus 8 pi and square root of 13, and we have to calculate it. So this is our answer, and of course meters squared. B. Later, the top part of the cone, a smaller cone of height 2 meters, is cut off, leaving a truncated cone on top of the cylinder. Find the volume of the part that was removed. So we know that here we cut off a small cone with height 2 meters. So we're left with 4 meters. However, our figure that left is no longer a cone because we have now to consider this small cone. So we can draw it. So here we have 2 meters because we have a smaller cone of height 2 meters. So we can use basically the knowledge that our cones are similar. They have the same apex, and we can observe that here we have height 6. Here we have height 2. So this height is divided by 3 in order to have 2. So now we have to divide 4 by 3. So this is our new radius, and the same with slant height. So this 2 and square root of 13 over 3. And now we can calculate the volume of right cone. So 1 over 3 times pi times r squared, so our radius, so 4 over 3 squared, and times height. And height is 2, because it's our new height, and now we can calculate it, and from our GDC we have 3.72, and here we have meters, cubic meters. And C, compare the ratio of the volume removed to the original cone's volume, and sorry, here was B. So we have to compare our this volume to our original cone's volume. However, we haven't calculated before, so now we can calculate our volume of the original cone. So volume equals 1 over 3 times pi times r squared, so 4 squared, times height, so times 6, and this is 32 pi, so we can write that this is 100.5, and now we have to write the ratio of the volume removed to the original cone's volume. So basically our 3.72 over 100.5, and this is 0.037. And that was the last problem from this measurement topic. And if you found this video helpful and useful, please leave thumbs up, subscribe to my channel, and in case of any questions or any doubts, you can write them down in the comments down below or via my mail, and you can read in the description about a little contest.